Now we're going to talk about precipitation rate and if systems are matched precipitation rate or not matched precipitation rate. Traditionally, systems with nozzling were not matched precipitation rate, and the only way that you made a system match precipitation rate was to vary how long the station was on, and that's how you would match precipitation rate your system. Now in this example, would you say that this is a matched or unmatched precipitation rate system? Now the 2's represent the flow of each one of these heads. So each one is 2. So the quarters 2 GPM, the halves 2 GPM, the fulls 2 GPM. So now if you answered that this is a matched precipitation rate, you'd be incorrect. This is not matched precipitation rate. So even though the flows are all the same, which are matched together, the precipitation rate is not. And I have a good little example up here. So you take the quadrant and the total flow. So the total flow for each per your area. So total flow is 2 GPM. So in one quadrant, the quarter, you have 2 GPM. Now a half, you have 2 quarters essentially, but you only have 2 GPM. So for the total of 2 GPM, you only have 1 GPM in each quarter. And now over here in your full, you have 4 quarters that make it up, but only 2 GPM. So that's a 0.5 GPM in each. So this is how you can see that if you have all these on the same system, your quarters in this area, which is the same area as these other quarters, is going to be extra wet because this is putting down 2 gallons, where this is only putting out 0.5 gallons. So there's a significant difference that adds up between 0.5 gallon, 1 gallon, and 2 gallons in the same area. So the only way in this system, if we all use 2 GPM to make this a matched precipitation rate, is we'd have to use 3 different valves. We'd put piping to just the quarters and put that on its own valve. Then we come to the halves, the 4 halves, and put that on a separate valve. And then the fulls, we'd put on a separate, this single full on a separate valve. So we'd have 3 valves, extra piping, but then we could match precipitation rate by running the quarters for, let's say, if it was 1 minute, we'd run it for 1 minute, then we'd run the halves for 2 minutes, and then we'd double that again into running the fulls for 4 minutes. And that would be then match precipitation rate. And we'd do that then in the controller. So where this is still typically done is large ball fields and with large rotors. They don't have match precipitation rate and rotors that shoot 50 to 60 feet. So that's where we would then have all the same GPM in the head, and we would just put different valves for halves versus quarters and fulls. So as you can see, if we were doing this for a residence, that would eat up a lot of valves. And that's where match precipitation rate nozzles came in, and they reduce install and labor and material cost. Now in this example, our quarters have 1 GPM, our halves have 2 GPM, and our fulls have 4 GPM. Would this be match precipitation rate? If you answered yes, you are correct. So as you can see, 1 GPM, you have 1 unit in the quarter, and then 2 GPMs for your halves. You still have 1 GPM in each quarter, and then for your fulls, you have 4 GPM with 1 GPM in each quarter, which then would allow you to valve this all on one valve, and you could then put this on one valve if you had enough flow to run all heads, and they would then run the same amount of time, and you'd evenly be putting down the same amount of water. Now we put our flow in our heads. You'll see over here it will say flow. So these Rainbird heads, so a quarter, an 8/4 has a 0.29 flow GPM. The half is almost double, so 0.59. So this was almost a 0.3, so doubling it is almost a 0.6. And then doubling the half, it would be 1.2. This is just a little off, but just like life, nothing's ever perfect, but it's within the tolerance to then call this matched precipitation rate. And so this would be pretty equal of putting the same amount of water across the entire landscape, and this is what we strive for. So again, typically your spray nozzles and your rotator nozzles are matched precipitation rate. Some smaller rotors have specialty nozzles that are matched precipitation rate, but standard rotor nozzles and large rotor nozzles are not matched precipitation rate. And that's where you would have to then valve them separately like the previous example.